Hello everybody, welcome back. We're going to continue on looking at Part A of the 2011 Csmc, that's the Canadian Senior Mathematics Competition. We're up to question 4, so let's dive right in and take a look. Alright, question 4. Determine the number of positive divisors of 18,800 that are divisible by 235. Okay. Seems like a very straightforward question. Certainly one of the shorter questions in terms of what they're talking, how much they're saying. Question 1's a little shorter, but other than that, everything else is pretty lengthy. So, number of positive divisors. Well, anytime we're trying to count divisors or factors, I immediately think prime factorization. Because if you prime factorize a number, you can easily tell how many positive divisors it has. You add 1 to each of the exponents and you multiply them all. Okay? But we want ones that are specifically divisible by 235. So if it's divisible by 235, then instead we could write it as 235 times x. Where x is a positive integer. Okay. Now, since 235x is a factor of 18,800, well, what does it mean to be a factor? It means that we can find a positive integer y, so that 18,800 is 235x, the one factor that we're talking about, times y, where y is yet another factor of 18,800. Okay. Now, we can get a relationship between x and y if we divide by 235. I believe it's 80, but let's just double check on our calculator. Yeah, 80 is equal to x and y. So this x value, if we could count up the number of x values, the possible x values, we'd be able to count up the number of factors of 18,800 that are multiples of 235. Well, now we know a little bit about x. So, not just any, it's exactly. In fact, exactly. The factors whole thing boils down to counting the factors of 80. The factors of 18,800 that we want are to form 235x. Each of these is uniquely determined by the positive integer x. Okay? Well, exactly the factors of 80 are the only possible values that x can be. So we just need to count the factors of 80, and that will give us the possible values of x, which will then tell us how many possible 235x's we could have. So to count factors of 80, we prime factorize 80, and I believe that's 2 to the 4 times 5, but let's just double check. 82 times 2 times 2 times 2, that's 2 to the 4, that's 16, times 5, that's 80. So we have the prime factorization. 2 to the 4 times 5 to the 1. So to get the number of factors, we take each of the exponents in turn, add 1 to them, and multiply each of those sums together. So if we had something else, if we had like 7 to the 2 over here, we'd have another 2 plus 1 multiplied together here. So we have 5 times 2, which is equal to 10. So our final answer would be 10. I don't want to start on a new page. That'd be a tad wasteful. Yeah, so the question boiled down. We were able to work it out so that instead of counting, factors of 18,800 that also happen to have a factor of 235, and I'm sure you could do it that way, we reduced it to simply counting all the factors of a particular number, in this case 80. Once we know it's 80, well, there's a simple formula for counting the factors, as long as we prime factorize the number. This is something that is handy on questions occasionally. And, yeah, simple formula works out 10. 10 is exactly what we want. We've already explained why. We just need to count the factors of 80. That gives us the possible x values, which gives us the possible 235x's. So, 10's our final answer. And there's not a whole lot else to say, so hopefully you guys will join me in the next video for question number 5, which looks like it'll involve a bit of circle work. So, I'll see you guys next time.